Good afternoon, everyone. I'm Gabriele Barlacchi, PhD student in AI for Society at the Scuola Normale Superiore at the University of Pisa. And my studies focus on evaluating the effect of recommended system have on societal and individual level. And with the work we are working on online and streaming retail, analyzing all the broader aspects that compose such a complex systems. The time evolution of those kind of systems bring with it many different effects that are pretty known in the literature, like filter bubbles or echo chambers effects, bias amplification, and the tendency of homogenization of user preferences involved within a system. So I'm going to talk about two ways of study those effects. The first one are empirical studies that rely on real observations and experience to gather insights or draw conclusions. And I will go straight to an example of a controlled study, which is a subcategory of empirical study. The paper of Lee and Zanagar explore how collaborative filtering models influence the diversity of products, specifically within a Canadian online retail platform. And the experiment covered 2 weeks, and the authors used an A/B testing platform that comes out with almost 3 million of user individual level interaction. So the foundation data is pretty good. And the experiment is composed by a control group that receives no recommendation within the platform. We are talking about the advertisement that sometimes we see on the websites, like users who bought this also bought that, something like this. And then the 20% of the users were assigned to 2 treatment groups that received recommendations from 2 different kinds of collaborative filtering models. Just a few words on how a recommended model works on this type of system is to see the item that a user is seeing when we scroll a website or a platform, and also evaluate the interactions or the past interactions of each user, in this case 60 days before, in order to suggest an item that a user never saw or never interacted with. Also, the recommended models are retrained every 3 days with a continual training phase. What is evaluated is the Gini coefficient, which is a widely used metric in order to evaluate the inequality of a given distribution, and applied to this kind of systems meaning that an highest value of Gini refers to a lower inequality, which is directly linked to the diversity of the purchases of the users in this case. As we can see here, in the y-axis, we have the aggregate measure of Gini that refers to the collective of the purchases of the users, and in the x-axis we have the three groups. We can see how the treatment groups have a higher Gini of a higher value of Gini, meaning a lower diversity with respect to the control group. The same idea is then applied to the individuals, and in which we have the opposite effect. So the treatment groups experiencing a higher value of diversity in the purchases the user made with respect to the control group, even if the values, the difference are very small. It's worth noting that a very small change of Gini value reflect a considerable effect at a market level. So we need to keep in count also very small changes. Also, the authors finally analyzed the co-purchase networks, which is composed by the nodes that are subcategories of the items. The size of the node is directly related to the overall sales of the system related to the genres in this case. And also the edge represents the fraction of users that share any couple of nodes. So, for example, people that like drama are also likely to engage with action movies, for example. And they note that also, with respect to the treatment group in the right graph, we can see how the density is higher, so the graph is more well connected, and we can get the same insight that we got before from the Gini video, meaning that the users are in some way cross-explore a bit more the system in a treatment group with respect to the control group, but this is done with respect to a small amount of categories, in this case of genders. So there are the so-called rich-get-teacher bias. So consumers cross-purchase more. At the same time, the exploration is related to the models that are applied over the system, and the market have a tendency to the top-selling products, which in volume keeps increasing, creating the rich-get-teacher bias. So is this whole story? No, of course. Also in a recently released survey in which our group worked, we saw there are many different outcomes depending on the scenario, depending on the methodology, and so on. And specifically about the diversity, there are a bit of confusion. This is why are also important simulation studies in which we can actually simulate users and interaction, and I'm going to present the idea of the project we are now working on with the group. The simulations help to isolate specific mechanisms. So we want to understand something about recommender model or choice model or whatever it is. It's of course better with respect to the online experiment in which we don't have so much control. Also, the experiments are scalable and repeatable differently from online experiments. So how the framework works here is starting from a data initialization in which the system is built. So we can consider the cold start period from which we can build every component that I'm going to show you. The first one is the recommended system. We can apply any kind of recommended system to the framework in order to evaluate the different recommended models we want, and they are trained on the actual data we have at the basement of the framework. Then we need to define how the population within the framework or the dataset we are considering is behaving. This is done using a choice model. It's pretty hard because, of course, it's highly dependent on how you model this behavior and also the outcomes that we will finally see. And then we can model also the penetration level of the recommendation models. That is a kind of reliance of the users with respect to the recommendation. So how they trust the recommenders the model gives. And this is done within a loop, the so-called feedback loop. So even here in the simulation, we can retrain the model whatever the time is it. We can update the data set, so the choice model, and so on. I'll just show you an example of the framework applied to a recently released dataset from Amazon e-commerce website, which covers 4 years of data. And just to show you a parallelism with respect to the previous work, here we see on the left the average Gini user, so the individual Gini computed at the individual level with respect in the x-axis of the adoption rate. So from left to right, there is a more penetration of recommender models. And so the Gini is decreasing, meaning that the diversity is kind of increasing in the individual part. At the collective level, the situation is different because it depends on the model, suggesting that the interaction nature is more, it's a bit more complicated, need to be well understood. Also, I also did some kind of comparison with the paper before, so we can analyze also here the co-purchase network, and we can do this whatever our objective is. In this example, I can show you the initialization phase from the cold start period, and then what happens after 2 years of simulation given a recommended model, for example, the BPR model. But we can also analyze the difference between 2 models, something that we cannot do in online experiments. And so this is just an example of how we can compare 2 papers, 2 works that are from a different nature, but we can some kind find an alignment between them. So in summary, yeah, we can see that at the individual level the diversity increase, at collective level decrease, and we can in some way repeat the experiment of different families. Moreover, in the simulations, we can see how everything is changing depending on how you model something. So depending on recommended systems, the specific strategy you apply, the data set, and the user behavior patterns you want to simulate for the population. So what are the main takeaways? Of course, controlled studies, like the previously we saw, is kind of disclosing the real behavior of individuals, but it lacks on generability and reproducibility. Meanwhile, the simulation studies are quite flexible and reproducible, but of course the outcomes highly depend on how actually we build the simulation and all the components that we saw. As already highlighted at the start, also the diversity nowadays, it depends on the recommended, depends on the system. So we need to understand how also to have an evaluation, a general evaluation, all the platforms we are using every day, because we are part of this playing, and so we need to understand how everything is changed depending on which application we are using. So what's next about our work is to create a systematic framework that can help to unify methodologies and so also enable across study comparisons, and finally also a model in order to simulate user behaviors, because nowadays it's a kind of open problem. And we want also to face it within this kind of simulation framework. I think it's enough. Thank you for understanding.
Any questions? Gabriele? Please.
Yeah, I'm curious about the second point of the what's next. So can you give us some ideas of how you want to
No, it's fine. And so the user choice model. Yeah, it's a problem that we are kind of facing now, because until now we are just thought, okay, we are just simulating individual preferences, so just people that moving with his individual preferences. Now we have proposed an our choice model that starting from the initialization data try to fit is a multinomial logit model, for example, our proposal, and then it fitted within the data, and then the simulation proceed with this model that it's not far away from a recommended model actually. So it's also kind of hard to divide the objective of the model. The theory is that you would like to simulate both individual and collective behaviors, but it's not easy. You can just, for example, easily simulate individuals, but then a collective independence. You have just, for example, if you have the real data, so you can work on that, but if you compare, for example, the collective behaviors, they are not the same. So it's quite hard.
Thank you.
Quick curiosity, perhaps I misunderstood what you're saying, but when I, as a consumer, when I looking for socks, I would like to have the socks, not the hats or shirts. So I would like to have a Gini coefficient, which is very small.
That's true, but it depends also in what kind of platform you are, and not always it's about socks. For example, here we are also talking about different kinds of socks. So if a recommended model gives you like 2 or 3 socks advertisement or socks companies, I don't know how holders. Well, I think this is a problem. So in this sense, the diversity is measured, depending also on the brands that they recommend that you know. Sure.
We did also an experiment with the supermarket, right?
Yeah, this is dependency. We have also supermarket data set, for example. So Amazon is referring to every kind of types of items. So it's also depending on kind of, and this is our secondly, let's say, objective, understanding if some patterns are shared among different situations, so depending on what we are using.